All right, example 8, it says to sketch at least one cycle. What does that mean for you, sketching at least one cycle? Yeah, from high point to high point, low point to low point. But it leaves the door wide open for you to go above and beyond and sketch more than one cycle, right? It does. And I'm always asking that you sketch at least one point to the left of the y-axis. All right, so sketch at least one cycle of this function right here. Label all of the things, blah, blah, blah. Okay, I'll talk you through it. What's the parent function here? Sine. There it is. So it's a modified Sahala. Is it in standard transformation form? No. So that would be kind of your first step. Put it into standard transformation form. F of x looks good. That's its name. By the way, don't forget the f of x. If this is a free response and you're just working with the expression and you don't have the f of x, you're going to lose a point. It is an equation. The 3 in the front should go where? At the back. It's your d value. So you have negative 2 sine of. And on the inside, that's where you're potentially going to have a little bit of work to do. You need to have the x term first, which it is, right? But in order for the shift, the phase shift to be accurate, you need to have the coefficient of x be a 1. And currently it's a 2. So inside the angle, you're going to factor out the 2 and you're left with x minus what? What do you get when you factor out a 2 from a pi halves? Pi fourths. Good. Because factoring out is dividing out. So pi halves divided by 2 is pi fourths. And again, very quickly before you proceed to check if you're right, just mentally redistribute. 2 times x is 2x. 2 times pi fourths is 2 pi fourths, which is pi halves. You know you have it right. Okay, so from here, let me kind of grab this and bring it over here. We can kind of give ourselves the stage notes that we need to graph it. The absolute value of A, the absolute value of B, C, D, P, and what letter comes next? R, yeah. A, B, C, D, P, R. So the absolute value of A is the amplitude, which is 2. Now here's where you're going to make a note to yourself. The A value is negative, which means we're going to be reflecting it across the what axis? We learned yesterday that the easy way to do that with Sahala and Chala is just to do what with your highs and lows? Flip them, right? So you flip your highs and lows. So there's a note to yourself to do that. B, the absolute value of B is what? Also 2. So how many cycles are we going to see between 0 and 2 pi? 2. Very good. Because B is the number of cycles you'll see in 2 pi. So if you're going to see 2 full cycles between 0 and 2 pi, what's the length of each one? Pi. Has to be. So once you find B, you can jump down here to P. Remember, it's 2 pi over the absolute value of B, which for us is 2 pi over 2, which of course is pi. It makes sense, right? 2 full cycles between 0 and 2 pi, so each one is pi. C and D, you don't have to put plus or minus, you just have to know which way it's going. So the C is the horizontal shift. Is it left or right pi fourths? Right pi fourths, so you can abbreviate right. Again, these are notes to yourself. And then D is up 3, right? Positive 3. So that's your sinusoidal axis. And the range, for what it's worth, we can find that because that'll help us when we're sketching it. What's our low point? 1? Very good. You go to the sinusoidal axis of 3, right? And then you go down by the amplitude amount, which is 2. So 3 minus 2 is 1. Hypotenuse axis at 3 and go up the amplitude amount. 3 plus 2 is 5. There you go. It's going to oscillate between 1 and 5. We are now ready to sketch the graph. So we need a y-axis and we need an x-axis. So I'm going to draw the x-axis like that, maybe extend it out this way. Hello. Okay, they're right there. Help yourself. Now, because our range is entirely positive, our x-axis can afford to be what? A little bit higher or lower than usual? A little bit lower than usual, yeah. So you can kind of modify it. It's kind of nice with notability. You can kind of shuffle things around. I think I'm going to move my y-axis over just a smidgen. I don't really need that many points to the left of the y-axis. Okay, so now we're ready to set the table, if you will. Now, the vertical axis is always the easier of the two to set up. Very easy, because we're going to be oscillating from 1 to 5. You want to do the easy one first or second? First? Okay. So if we're going to be oscillating from 1 to 5, I'm just going to put a dot right there or a line and call that 1, and then kind of preserve the skill and imagine 1, 2, 3, 4, 5. There's 5. You see 5? I label it as 5. Now, halfway in between there, that's your midpoint. What's the midpoint of 5 and 1? 3. Is that a pretty important value here? Yep, that's our y value of the sinusoidal axis. So what I'm going to do now is all the way through 3, I'm going to put a dotted or a dashed line, kind of a mixture of both. There you go. That's going to be your new sinusoidal axis. That's the one that you're going to reference when you do Sahala Chala. Okay, so that's it. Try to make sure on your graph that this distance above and below is in perspective on your paper, okay? Now, the horizontal axis, this is the one that could be potentially fun. If there's a horizontal shift, which there is, I don't want you to set up your axis on the final graph and then modify it in case they're different. So we set up a temporary sacrificial x-axis. So here's what we'll do. Here's 0, always start at 0, and you go out the length of one cycle, which is pi. Because I'm always going to be interested in having, you know, at least one cycle sketched, very detailed. So there's 0, there's pi. That would be one cycle. Half of that is pi halves, and half of that is pi fourths. And now you have your most important value on this graph. The quarter cycle counting interval is pi fourths, which you can get pretty easily, right? If the period's pi, just divide it by 4, and you got pi fourths. So even after we shift things, the critical values are going to be pi fourths away from each other. And for what it's worth, you can label that 1 pi fourths, 2 pi fourths, that would be 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, so on and so forth. But the whole reason we do this is just to orient ourselves to where the y-axis is going and what the new critical values are. If we are shifting things right pi fourths, boy, that again is a super easy shift, isn't it? Because we're picking up our y-axis, which is at 0, and moving it one critical value over and setting it right back down again in the exact same tracks. We don't have to have new values, but they are a-coming, and they are the fun ones. So there you go. 0 will still be a critical value. So I know that 0 is going to be one of them, and since I have my spacing kind of figured out already, you could just kind of put your first one down right there and call it pi fourths, and put your dotted line there for your y-axis. Now here's the thing. When you put two critical values down, consecutive critical values down on your number line, whatever the spacing is on your iPad/paper, that's the distance that you need to preserve subsequently for the spacing on all the other critical values. So now you can just kind of eyeball it. You don't have to take out a ruler or anything. Just eyeball it. And then we'll have at least one over here. I have room for 2. I'm not going to take out a device on yours, but if they are unreasonably spaced, you will lose a point. All right, so I got tons of values there. Now I just got to label them. Labeling is going to be kind of fun. You count by pi fourths and simplify as you go. This in and of itself is a pretty good little activity, right? Simplifying fractions. 1 pi fourths, 2 pi fourths is? Pi halves, good. And then we got 3 pi fourths. 4 pi fourths is? Pi. Then you got 5 pi fourths. 6 pi fourths becomes 3 pi halves. 7 pi fourths doesn't simplify. 8 pi fourths, 2 pi. 9 pi fourths, and then 10 pi fourths is the last one I have room for. 5 pi halves, good. And then going the other way, we got 0, so negative pi fourths. Negative 2 pi fourths is negative pi halves. There you go. We have now set up the x-axis and the y-axis with all of the important relevant information, and the intersection of our two dotted lines is going to be the new origin, which is where we start when we sketch by the Sahala Chala method. This right here, by the way, can accommodate any graph, sine or cosine, plus or minus. So now we return to the original function, and we're like, oh, It's a sine function that has the highs and lows flipped. Good to know. So we'll pick our favorite flavor here for our graph. How about red on National Women's Heart Day? Make it a little bit bigger too. Okay, so sine is Sahala, right? Let me write that up here. Sine is Sahala. So Sahala normally starts again normally on an axis and goes up. But because it's a negative sign, we're going to go on an axis and head down, right? I said you don't have to memorize it, but it's kind of fun. If you flip the highs and lows, you have negative Salaha. So here we go. At any rate, we're starting at the axis, which is our new origin. And the next point, as we go to the right, good morning. She is absent today, but I can hold on to it for Monday. Okay? Thank you. So we have an axis, and then we go low, and then an axis, and then a high, and then an axis, and then a low. And again, you're just kind of eyeballing these. And then a high, and a low, and then an axis, and then we're done over there. And don't forget, is 0 a critical value? It is. It's real easy to kind of skip 0, but in this case, it is a critical value, so you want to put it there. It won't always be a critical value, as you'll see shortly. And once you have all your dots there, then it's just to connect the dot party. And go ahead and connect them with your arcs. And I like to do it in quarter cycles so you can kind of exaggerate the curvature. Don't make them too V-ish at the highs and lows, at the local max and mins. They should be kind of curvy. And then turn the corner wherever you are and put a little arrow to indicate that this graph is like an Energizer battery. Keeps going and going and going and going. And we're done with the graph. Okay? And you'll see in the next section when we start applying it, it's going to make answering questions so much easier. All right, so once we have that, I can ask you to give me an equivalent equation of this graph in either a sine, cosine, plus or minus. So we started with a negative sign. That's how we generated the graph. Let's go ahead and write 3 other equations. We're going to need one with a positive sign. We're going to need one with a positive cosine. And we're going to need one with a negative cosine. We'll practice all of them. So if you recall from yesterday, this graph is what it is. So the only thing that's going to change, except for maybe the plus or minus value on the A, is the what? The what? The horizontal shift, the phase shift. All the other numbers stay the same. So you can kind of set it up. If you want a positive sign, because we started with the negative sign, it'll be positive 2 sine of. The B value is still 2, parentheses x plus or minus something plus 3. You can do that. Now with that little template right there, let's go ahead and write the next 2. If I want a positive cosine, it's going to be a positive 2 cosine of the B value still 2, x plus or minus something plus 3. And if I want a negative cosine, it's negative 2 cosine, parentheses 2, x plus or minus something plus 3. The absolute value of A is the same, the absolute value of B is the same, and the D value is the same. Okay, so now we can come back up here and make quick work of this. If I want to write a positive sign starts on a what? An axis. But you got to be careful because positive sign starts on an axis and it's heading where? Going up. So at what value of x are we on an axis going up? Negative pi fourths is a good one. So if I want to take my graph of sine, which would be unshifted right here, and I want to shift it left to match up with this, I would have to do what in my equation? Plus or minus pi fourths? Plus. Okay? Plus pi fourths. So that would work if you have plus pi fourths. If you don't want to go plus pi fourths, would minus pi fourths work here? No. Minus pi fourths would shift it to the right, and that would be on the axis heading down. So that could actually work well for the equation we were given. That makes sense. What could be another place that you could shift over for a positive sign? 3 pi fourths would be the next one. And if you needed to shift it to the right, it would be minus 3 pi fourths. So maybe you've got it figured out. It would just be the opposite sign of whatever x value you're looking at, right? If this is a positive 3 pi fourths, it's going to be a negative in the equation. If you want to shift it over to negative pi fourths, it's going to be a positive in the equation. You could also shift it over to 7 pi fourths, right? How far apart are 7 pi fourths and 3 pi fourths? Pi. They're coterminal with each other in this function. So there's infinitely many solutions. All right, let's do one for positive cosine. Positive cosine starts where? Axis high or low? High. How you doing? Good, good. So where does cosine start? High. You're pretty friendly. It starts at a high point, right? Where's your favorite high point? Right where it is. Which is, ooh, that's so zen. My favorite high point is where it is. At 0, right? At 0. I know what you meant. We wouldn't have to shift it at all because if there's no phase shift, it starts at 0. So you could just leave it like this. We probably have a surplus of parentheses there that we can get rid of, but you can leave it like that. Since I have the space, let's go ahead and shift it over somewhere besides 0. Where else could we shift it to? We could shift it over to pi, so it would be minus pi. That would work. Or minus 2 pi or minus 3 pi, so on and so forth. All right, so for a negative cosine, where does it start? High, low, or axis? Low. Low. Where's your favorite low point, or anybody's favorite low point? You like pi halves? So would it be plus or minus? Minus. Minus. If you want to shift it over to pi halves, it's minus pi halves. Would plus pi halves work there as well? Yeah. In this case, it would, because that shifts it to the left. So again, once you have the graph done with all the critical values labeled, this is a pretty easy task, or should be a pretty easy task. Okay, any questions on that one? Absolutely, yeah. We would probably clean it up. 2 cosine of 2x plus 3. You wouldn't need a phase shift. Mm-hmm. All right, let's, I guess we have to do 9. It's right there. I wanted to skip it and get to the fun ones, but all of these are good. I've already cultivated all these and grown these in a laboratory, and they're ripe for the picking. So let's go ahead and do it. Sketch at least one cycle of that, and then blah, 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 blah. Okay, there's a lot of stuff there I'm not going to read. You can read it if you want. What's the parent function? Sine. Okay, that's pretty easy. Is it in standard transformation form? No, it's not. So we need to get it into standard transformation form. F of x equals, let's see, the negative 2 is okay. It's sine of. Now on the inside, we have a little bit of work to do. That's really the only problem with this. I need to factor out a what from both terms in the inside? A negative pi. So negative pi, and then x what? Plus or minus? Minus. And when I factor out a pi from a pi halves, it's what? 1/2. Very good, because you're dividing out the pi. Again, a quick mental redistribution tells you that you're correct. All right? So let's go ahead and take inventory. We'll scoot this guy over here now. And our little stage notes to ourselves. The absolute value of A is what? 2. But because it's negative, we're going to have to flip the highs and lows again, aren't we? Just like before. The absolute value of B is what? Pi. But it is negative. Uh-oh. What happens when you have a negative B value? In general, what does it do to the graph? Flips it across the y-axis. Reflection. That's going to be a little bit harder to sketch, isn't it? You can't just like flip your highs and lows vertically as you're going from left to right. You're going to have to like sketch the entire graph first and then take it and reflect it across the y-axis and re-sketch it. Oh my gosh. That's going to take a lot of time. Do we have that much time? No, not if we want to go around at the end of class and say what we're doing this weekend. We don't have time for that if we're going to be doing that. So is there a faster, shorter way to do it? Hopefully. I sure don't want to reflect it across the y-axis. I sure don't want to do that. Can y'all help me so I don't have to? I still want to get the right answer, so don't just say, then don't do it. It's up to you. You get the wrong graph, you don't have to do it. I want to get the right answer, but I don't want to have to flip it across the y-axis to do it. Graph from right to left. How's that going to help? Oh, when I plot them, like instead of like a positive pi halves, just put it at negative pi halves. That's a great idea. I like that. That actually is something I can work with. Does everyone understand what he's saying? Just like take the x values that I would normally have on my sacrificial x-axis and then just plot them over in negative line. I like that. That still seems like a lot of work, though. But that's a great idea. I like that. I was thinking more about, maybe I could use the symmetry of the sine function to just avoid it altogether. Was sine even or odd? It was odd. And what was the consequence of an odd function? It has origin symmetry. Very good. Which means what? It's in your notes because it's right here. It means sine of a negative input is equivalent to the opposite of the sine of the positive input, right? We've studied even and odd functions this year. So if you have a negative angle and you have an odd function, what can you do? You can essentially bring that negative where? Out front. That's the consequence of an odd function. What would be the consequence of an even function like cosine? If you have a negative angle, what can you do? You could just forget about it. You can just get rid of it altogether. But if it's an odd function, you have to deal with it by bringing it to the front. There you go. So you can use the symmetry here. So before I get too into all this flipping and reflecting, let's go ahead and simplify this equation. I do have a negative b value. And because sine is an odd function, I could bring that negative out front, and combine it with the negative that is already there. And what's a negative times a negative? A positive. So I get 2 times sine of pi, x minus 1/2, close, minus 5. And I'll get the equivalent graph. Now let's take inventory. The absolute value of A is 2, but are we going to be flipping the highs and lows anymore? We are not. That's awesome. That's one less thing to do. And do we have the negative b value anymore? Nope, we don't have to flip it at all. So there you go. Anytime you have a negative b value for a sine or a cosine, you do not have to do a y-axis reflection. If it's a sine function, what do you do with the negative b value? Take it out front and change the sign of whatever a is. In this case, it was negative, so it became positive. If it started positive, it would become negative. And if it's a cosine function and you have a negative b value, what do you do with it? You just what? Take it out and do what? Throw it away. Dispose of it. Get rid of it. Forget about it. It's gone, right? Question. Had a hand raised. Yeah.
On cosine, if A was negative and B was negative, would A still be positive?
On a cosine function, if A were negative and B were negative, you would get rid of the negative b value. You would just get rid of it. A would stay negative. It does not change the sign. It doesn't affect A at all. Okay? All right, so let's proceed now. C is going to be what? Left or right a half? Right, 1/2. D is up or down 5? Down 5. Okay? I always thought that down 5 would be like a command you would give to like an unruly dog that jumped up on people if its name was 5, right? That's what you'd say. Down 5, down. Does anyone have a dog named 5? No? Okay, what's the period? 2. Pi over what? B, which is pi. Good. So the pi's divide out and we have 2. For the first time, we have a cycle length that doesn't have pi in it. Bless you. And the range. What's the low point? I like the -3, but not for the lowest point. We take our d value, which is -5, and we go down the amplitude amount. So -5 minus 2 is -7. And then for the high point, we go -5 up to for a high point of -3. So our graph lives entirely below the x-axis. Okay? So that's going to be helpful when we're sketching it. So here's our y-axis. And our x-axis, we can afford to draw a little bit higher than usual. And I'm going to scooch my y-axis over. Doesn't need to be over there. Okay, there we go. Let's do the fun axis first, the x-axis. We'll save the easy one for the end this time. Is there a phase shift? Yes. So we better make our sacrificial axis. Here's 0, and we go at the length of a cycle, which is 2. Half of 2? 1. Half of 1? A half. Guess what the most important interval on this graph is? 1/2. Everything is going to be 1/2 unit away, pre and post shift. So that's going to be 3/2. Now look at it again. Boy, I'm making these nice and easy for y'all. We're scooting the graph to the right 1/2 unit. Oh my gosh. That again is just picking it up and moving it one critical value over and setting it back down. I thought these were supposed to be interesting. Well, this one is interesting because there's no pi. There's 0. Here's 1/2. That's my new y-axis. And again, once you have two critical values put down on your paper / iPad, you need to preserve that distance as you put down subsequent ones. So just eyeballing again. No. How many critical values do we need for one cycle? 5, right? So as long as you have 5 going to the right, make sure you have 1 going to the left, you're good. That'd be kind of the rule of thumb. If you have too much x-axis, just kind of erase it, you know. All right, so now we'll just count by halves, like we're in, what, 5th grade? When did you count by halves? Did you ever count by halves? 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves. Maybe you're dividing out Skittles or doling out Skittles to your friend. You don't cut Skittles in half, do you? No. That was kind of boring. That wasn't that fun. All right, let's do the easy one then. The vertical axis, -3. I'm going to call that -3. I'm going to kind of get below my marks, and then I'm going to go way down here and call that -7. So there's the high and low, and then right in the middle, kind of bisect it. That should be your D value, which is -5. And again, you can average them together. -3 plus -7 is -10. Half of that is -5. That's how you find the average of two numbers. You add them and divide by 2. And so now I'm going to draw a dotted line all the way across. There we go. And now we have our intersection of our new X and Y axis. I'm going to choose pink for this graph, also in honor of National Women's Heart Day. And boy, it started off as a negative sign with a y-axis reflection, and it ended up being just a plain old Sahala, right? So here we go. We start on the axis, which is right there, the intersection of our two dotted lines. And as we go to the right, it's axis, high, axis, low, axis, high, axis. Is 0 still a critical value? Yep. So as we work backwards, we hit a low point at 0, -7, and 1 point to the left, we hit an axis. We connect the dots with our quarter cycle arcs to make it look pretty. We put a little arrow at the end to show that it keeps on keeping on. And there you go. There's your graph. That's about as detailed as you need to be. Your x-axis is labeled. Every critical value is marked and shown. Your high and low and sinusoidal axis are labeled. Perfect. Okay, so now it's time to write the equations of the other functions. We technically started with a positive sign. So let's go ahead and write equations for the other 3. So if you want to kind of get them laid out here, f of x is going to equal, let's go ahead and do a negative sign. So it'll be a -2 sine, parentheses, pi, x plus or minus something, -5. F of x equals, what do you want to do next? We have to do the cosine. Do you want to do positive or negative first? Positive. So +2 cosine pi times x plus or minus something -5. And we'll finish with f of x equals -2 cosine, parentheses, pi, parentheses, x plus or minus something minus 5. So again, this template format makes it real easy because you're focusing on all the stuff that's the same. And then you're coming back as a second endeavor and you're finding the x values that you need. All right, so let's go do the top one. For a negative sign, we need to be where? Going down from a what? An axis. So the most convenient place where we're on an axis going down is probably -1/2 or +3/2. So there would be two answers in this case. You could have a +1/2 or a -3/2. Based upon your graph, that would work. You could also have a -7/2 because we are showing that one. So either one of those would work. For a positive cosine, we need to be where? At a high point, right? And the closest one, I think, is 1, right? So to get to 1, would we do +1 or -1? -1, good. You could also have -3. And then for a negative cosine, we need to be at a low point. Where's the most convenient low point? At 0. Very good. So if you want to kind of remodel this, like, ooh, we didn't need all those parentheses. We'll just take them back to the store. Good thing we have a receipt. Okay. No receipt? Okay, store credit. I'm fine. I shop here all the time anyway. There you go. So that's it. Okay. Example 10 is kind of the same thing. These are getting kind of boring, aren't they? Which means you're getting good at them. If they're getting boring, that means you're getting good at them. The only thing on example 10 that's worth noting is we do have a cosine, and it's going to have a negative. So let's not graph it, but let's go ahead and put it into standard transformation form. And then we'll move on to a fun one. F of x equals, where does the 2 go that's in the front? In the back. So I have a -4 cosine, parentheses, leave a space, +2. Now I'm going to switch flavors to green here. You have to do two things on the inside. Number one, you have to have the x term first. It currently is not. And then you have to factor out its coefficient from both terms. So I'm going to factor out a -3 from the x and flip them around. That leaves an x, what? Is it still a minus? It's going to be a plus because I factored out a negative from the negative pi, so it's a plus. And what do you get when you divide a 3 out of a pi? Pi thirds. Yeah, factoring out is dividing out. Once again, a very quick mental redistribution will show you that you're correct. And make sure that for every parenthesis you have open, you have another one that's closed. It's real easy to forget the closed one. So we actually have two sets of parentheses there. One for the entire angle, and then one for the two terms that are the horizontal shift. Okay, so the -4 in the front is going to flip it and make it negative Clahow. But the -b in front, again, we don't want to have to do a y-axis reflection. So because it's cosine, cosine has what type of symmetry? Y-axis symmetry. So for a function that's even, what do we do with the -b value? We just drop it. It goes away. The -4 in the front stays the same, and we get +3 times x plus pi thirds plus 2. And Kevin, that was your question a little earlier. You just drop it. For an even function, the -b, I like the word drop because then it goes away. If it's an odd function like sine, we have to bring it out front and change the sign of whatever the a value currently is. Okay, so from there we could sketch it like we've been doing. What would the range be real quickly, since we're here? -2 to 6, good. What would the period be? 2 pi thirds. Excellent. Those two questions you should be able to get quickly from the equation. All right, so the next one. It says, sometimes the new period and the phase shift lead to critical values that aren't so quote-unquote nice. We've been doing some pretty easy ones, right? Picking it up, setting it down in the same grid. That's not always going to happen. Example 11. What's the parent function? Cosine. Okay, good. It's some kind of chala. Is it in standard transformation form? No. Thank goodness. It means we have some work to do. And it's fun work. It's like digging for money. It's fun work. Someone buried 10-pound bags of $100 bills, and our job is to dig them up. We get to find what we keep. That's good work. We get to find what we keep and keep what we find and smile the whole time. Yeah. We get to find what we keep. Does that even make sense? I don't know. Hey, the 3 in the front goes where? In the back. So it's 2 cosine of, parentheses, plus 3. And on the inside, we get to factor out a what from both terms? Pi fifths. Yeah, we do. The first term's easy. That's x. We don't change the sign, so that's a minus. Now, what do we get when we factor out a pi fifths from a 3 fifths? Or 3 pi fifths? 3. Good. Close that parenthesis. Quickly mentally redistribute, and you see it's right. If you're not sure how that works, we take a 3 pi fifths, and we're dividing out a pi fifths, and you can stay, change, flip, right? Stay, change, flip. Stay, stay, down 5, stay. All kinds of dog commands today. Change, change. That's a harder one for the dog to do. Change. And then flip. I bet that one's easier for some dogs. Don't make your dog change. If you want your dog to change, just get a different breed. Because they have temperaments, you know. All right. 3. And it works. Got it. All right. So now that we have that, let's go ahead and list our information. Stage notes over here. What's the absolute value of A? 2. That's the whatlitude? Amplitude. Are we flipping it? Nope. What's the absolute value of B? Pi fifths. Okay, so how many cycles are we going to see between 0 and 2 pi? Pi fifths. Great answer. You're catching on. C, what's our phase shift? 3 to the right. Right 3. Good. What's our D value? Up 3. Right 3 and up 3. Okay, good. What's our period? It's 2 pi over pi fifths, right? Which makes it 10. Ooh, no pi. That's nice. No pi. And then right here, the range. One last thing, the range. What's the low value? 1, and the high value? 5. Okay, good. So now we're ready to make our sacrificial axis. We do have a phase shift. We're moving it right 3. The period is 10. As you're going to see here, we're moving it over into a different spot. So there's 0, there's 10. Half of that would be? 5. That would be your half cycle. And then half of 5 is? 2.5. So we're counting by 2.5. Now, if you prefer to call it 5 halves, I get that. So we're counting by 2.5. So the next one would be 7.5. Now, 2.5, remember, is the most important number on this graph. It's a fourth of 10. You could just do 10 divided by 4 if you needed to. We're going to shift everything over what? 3 units to the right. So the y-axis goes from 0. It's going to move over an entire critical value plus a little bit more, and it's going to fall right here at 3. Now, here's where you need to be careful. What would the next critical value be before the shift to the left of 0? Negative 2.5, right? If you were to move that critical value 3 units to the right, where would it land? It would land, what's negative 2.5 plus 3? 0.5. Just 0.5. So notice, this is why it's tricky. 0 is your y-axis. It's going to stay there. You're going to have a critical value at 0.5, and the next critical value, which is the new y-axis, is going to be at 3. That's the spacing that you need to make sure you have. That's why you do this. And if you could do that without making your sacrificial axis, that's fine. Okay? Everything is going to shift over. Where does the 2.5 go? It goes over here to 5.5. Where does the 5 go? It goes over here to 8. Okay? So everything is going to be offset just a smidgen to the right of the previous ones. So that's a little bit of planning. That's why we do the rough draft. Now we're ready to make our graph. It's from 1 to 5, so it's entirely positive. And here we go. We're going to put down our values. We've thought it out. The first critical value is at 0.5. I'm kind of establishing that distance now off the y-axis as a half a unit. The next one has to be 2.5 away, which is at 3. Now that I've established the distance between two consecutive critical values, I need to try to preserve that. So there would be the next one. There would be the next one. Keep going over here. And maybe one more right there. And now I need one more to the left. So I keep that distance right there, and it's going to be about right there. These are the two most important values on the graph in terms of you setting it up. A lot of students are going to miss that first one at 0.5. If you don't draw that sacrificial axis, you're going to miss that point. Okay, so now we can just label them. How far apart are they? 2.5. So let's just add. What's 3 plus 2.5? 5.5 plus another 2.5. 8 plus another 2.5. 10.5 plus another 2.5. 13. Good. And working back 1, we get -2. Good. There you go. That is the hardest part about this. Getting the spacing right when it's new critical values. Is 0, the y-axis, a critical value now? It is not. Now the vertical axis is still going to be easy. It's going from 1 up here to 5. The midpoint is 3. That's easy. Or not as fun if you want to think about it that way. Now to finish it up very quickly here before the bell catches us, it is a positive cosine, so it's chala. So you go to the intersection now of your x and y axis, and it's high, axis, low, axis, high. And you work backwards now. It's an axis point at 0.5. It's a low point at -2. 0 is not a critical value anymore. And there's your graph. And of course, from there, you can write an equivalent equation in terms of sine, positive or negative, cosine, positive or negative. 0 is not a critical value. This 0.5 is. If you find yourself drawing your graph and your graph doesn't look like it's going up and down symmetrically, like it seems like it's crunched up or bunched up in one place, you're probably missing a critical value. These are the type that we're going to practice on Monday, because these are the type that are really pre-AP type level and not the other easy ones. But we've worked up to them. So it's a nice way to end on a Friday. All right, what are y'all doing this weekend? Math homework, a little bit? A little bit. Not too much, right? Too much of a good thing. Have a great weekend. It's only